All right, today we are actually going to review a little bit over the substitution and elimination methods of solving systems of equations algebraically. Okay, so for substitution, what you want to do is solve for one of its variables. It could be x or y. It does not matter which one or whatever variables they have. Like here in a second, we're going to have p and q. So solve for one of the variables. Substitute the expression from step one into the other equation and solve for the other variable. And then once you do that, you're going to get like an x or y value, hopefully at the end, like x equals 10. And then you're going to take whatever that answer is and you're going to plug it in to the other equation, and you'll be able to, or I'm sorry, not the other, either of the two equations, and then you will be able to get the second part of your answer. So let me show you what that kind of looks like here. So once again, you can solve for x or y. So in this case, I'm going to solve for x on this first equation. So if I'm going to do that, I need to move the 2y to the other side. That's going to be x equals 2y plus 1. Okay, and then what we're going to do, since this equals x right here, so I'm going to plug that right in for that x right there. Okay, now anything you plug in, you need to put parentheses around. So I'm going to put 2y plus 1 in parentheses, and then I'm going to write out the rest of the equation here. And I'm going to, so, yeah, we'll do plus y equals 4 right there. So all I did was I swapped out that x with the 2y plus 1. That's because it equaled x right there. Okay, now if you have parentheses, you need to check and see if there's anything to distribute. We don't have anything out here in front. We could say it's kind of like a 1, but when you distribute 1, that's not going to change anything. So we're just going to write this as 2y plus y, or I'm sorry, 2y plus 1 plus y equals 4. And some people will skip that step. You don't necessarily need to write that. Some people are going to go and combine like terms right away. So when you do that, you got 3y. So it's 3y plus 1 equals 4. We're going to subtract 1 from both sides. And then you're going to divide by 3. Okay, so that was actually step 2 that we just did there. So we now are going to go take that and go plug it back into one of the equations that we started out with here. So you can do the second one, you can do the first one, you can actually even do this modified one, which is what I'm going to do here. Because y is on that right-hand side, and then x is already by itself. So if I go plug that in, that'll be x equals 2 times y, or 2 times 1, and then plus 1. All right, and then once you simplify, you get that that is x is equal to 3. And then to write your answer, you can write it as 3 comma 1. That is it. Okay. Now, once again, you can go back and check your answers just like we did with the graphing. You can check your answers by plugging both, or the solution into both of the equations to see if that works out. For time's sake, we're going to go ahead and skip that, but that is definitely an option. Okay. Now, sometimes you'll get problems where there's a logical variable to choose as far as which one you want to solve for here. If I look here like this 4p right there, if I try to get p by itself in that equation, I'm going to have to do 2 steps. I'm going to have to subtract the 6q and then divide by 4, which could make fractions. So always look for easy variables to solve for. So if you go here in this second equation, if you look at that right there, we can get p by itself in one step here. All right, notice that there's an implied 1 in front of p, so we don't really need to divide by anything, which will keep us away from fractions. I know how much you guys don't like fractions, so let's try and stay away from them. So we're going to solve for this p here since it has a coefficient implied to be 1. We're going to do that by adding 3q to both sides. And then that is p is equal to 3q, and then I guess minus 17. And then we are going to take that and we are going to plug that in or substitute that in for the other equation and for p. Okay, so that'll be 4 and then 3q plus, or minus 17. And then you still have the 6q right there, so plus 6q, and then equals 4. Okay. Now, once you get that done, you're going to go ahead and distribute there. And I'm not sure off the top of my head. Probably do some mental math, but it is summer right now, so stay away from that. That is 68. Okay, and then you have 3 2q, so that'll be 12q minus 68, and then plus 6q, and then equals 4. Okay, and then I guess we will combine our like terms, all those q's right there, so that's 18q, and then that equals 4. And we're going to add 68 to both sides. So it'll be 18q 3 or 4 times. Let's see, 72 divided by 18 is 4, yep. So q is equal to 4. Equations, it can be either the originals or it can be this modified one, which actually I usually like to do it into that one. Okay. So what is that, 12? Have case where you do that. So usually I don't write these as ordered pairs. I just write q is equal to 4 and then p is equal to write it as an ordered pair, especially since those usually tied to graphs. Okay, C, this one's kind of a big one. This always freaks people out. They're like, well, what the heck's going on here? All this weird stuff with the fractions. So one thing I would like to do here, yes, y is by itself, but I definitely don't want to go and plug all this stuff in for that y right there. Not too bad. But one way we can get around all these fractions here is if we take this equation, and technically I need to write it like this here, we're going to multiply by something that's going to cancel out the fractions. So if we multiply by whatever the denominator is, those should cancel out. I'm going to multiply that right-hand side by 2, and that means I need to multiply this, and then that 2 will cancel out with that second denominator, so it'll just be plus 5. Okay. Now this second equation, we can actually get x by itself pretty easy. So that's what I'm going to do there. I'm going to subtract 2. And now that I have this, I'm going to go plug that in for my x right over here. And there's something real small that you have to be real careful when you're doing this problem right here. So I'm going to color code this well in front of the parentheses there. And I have a lot of students that will accidentally leave that and then plus 5 and then equals 2y over here. All right, now what's weird about this is if you get the two y's together, if you subtract 2y, both sets of y's cancel each other out, and you're just left with 0. And then on the right side, you have 5 plus 5, you have 0 equals 10. There is no solution. If you get something, we put no solution. Now, for example, I can't remember if we do see one like it eventually, but let's play the what if game. So like, let's say we're working out a problem. We get something like 5 equals 5. If we get something that's true right there, then we would say this has no solution. So that's if you get a thing that's not a contradiction. Over here, the 0 equals 10, that was a contradiction. That's why we said no solution. So be kind of, I guess, looking out for those things. Okay, let's see what we got going on here. I guess a word problem, maybe it's going to be smart to use substitution on this one here. A music store offers a piano lesson, or piano lessons, at a discount for customers buying new pianos. What is the cost of each lesson and the one-time fee for the materials? So sometimes we can use, substitution, what we talked about up there, to go and solve systems of equations. There are two unknown things here, so if you go and read carefully here, we don't know the cost of each lesson, and then the one-time fee for the materials, we'll call that y. And if we go back here and look at the flyer here, it's 6 lessons, it's $300. But, so we can't just say 6x equals 300 and divide by 6. We have to write it kind of like this. We're going to write 6x, 6 per each one-time fee, and then equals $300. Now the second equation here, it's very, very similar here, except we're dealing with, okay? So we're going to use substitution. Y's are pretty easy to solve for. I'm going to do the first equation, I'm going to solve for y. So I'm going to do that by subtracting 6x from both sides. And I'm going to say y equals 300, plug that in to the other equation. So substitute, and equals 480. Okay. Now, if you don't have anything outside the parentheses to distribute, it's kind of like having a 1. So we can go ahead and combine like terms right away. So 6x plus 300 and then equals 480. We're going to subtract 300 from both sides. I guess that gets us to 180 equals 6x. And then divide by 6. And I know 6 goes in the 8. In this case, if we're going back up here, equals 300. and then minus 6x. So what would that be? Minus 6 times 30. Okay, it's kind of looking bad there. Let's see if I can write better. 300. There you go. And then sometimes teachers it's $30 one time fee of, I guess, $120. And then that would be like your actual answer. Hopefully this is still recording. Okay. All right, so that is that. Next here, we're going to talk about the elimination method. This is actually the one I prefer the most. To me, it can be really, really quick. So with elimination, the whole idea is you want to add your two equations up, and hopefully, if you add your two equations up, like all the m's, all the n's, all the stuff on the right-hand side, if you add those up, theoretically something could cancel out. Right? And then sometimes we might need to manipulate some of the equations to make it to where something does cancel out. So for example, if we add these two equations, we have two m's altogether. But then when we add the n's, n plus negative n, those will cancel each other out. Okay, and then on this right-hand side, I guess we're going to have 11. And then we can go, and then after that, just divide by 2. That's m is equal to, I guess, about 5.5. You could use 11 halves if you wanted. I'll use 5.5. Okay, and then just like substitution, you're going to take your answer, you're going to go plug it back into one of those. So I'm going to do the first one. I'm going to say 5.5 plus n, and then equals 6, and then get n by itself. Subtract 5.5. Okay. So I'll get us n is equal to, I guess, 0.5, or 1/2, and that would be your answer there. So it's not too bad there. Now, sometimes they're not going to be as easy. A lot of them aren't going to be. Sometimes you're going to have to modify one of your equations. So like, for example, here, if you look here at B, if you try to add your x's, well, you're going to have 4 x's left over there. And then your y's, when you add them, you're going to have negative 4y right there. So nothing would actually cancel out. So this is where we're going to have to modify one of the equations. So you decide what you want to cancel. Do you want to cancel out your x's or your y's? And it doesn't matter. For this example, I guess let's go ahead and cancel out our x's. I guess it doesn't really matter. So I'm going to multiply both sides of the equation by something that's going to make this 5x cancel. So the only thing that would make 5x cancel is if this looked like negative 5x right there. So to get that, we need to multiply by positive 5. So if we distribute that 5, that's going to look like this. It's going to look like negative 5x. It's going to be plus 20y, and then equals negative 20. Okay, so that's our new equation right down there. Okay, so now when we add our two equations up, our 5x's should cancel out, which is nice there. And then our y's, it looks like we're going to have 12y left over. And then actually 20 and negative 20, that happened to cancel out as well. Okay, so that's 12y equals 0, or 12 times something equals 0. The only thing y could be is actually 0 there. Or if you're just saying 0 divided by just about anything is going to be 0. There you go. There's an elimination problem right there. You have to modify the equation. Now, as far as getting your other piece of the answer, you need to go plug it back in. I usually stick with one of the original equations. I don't do this 5x plus 20y minus 20 just because it gets so large with some of the numbers sometimes. So I'm going to do whichever one looks easiest. To me, that first one looks pretty easy. It's negative x plus 4 times y, which we found to be 0, and then equals negative 4. Okay, and then after that, 4 times 0, anything times 0 is 0. So that's basically negative x is equal to negative 4. And then divide both sides by negative 1, which would change your signs, and x is positive 4. And then if that was like on a graph right there, we could write that as an ordered pair 4, 0. And then there you go. All right. Now, every now and then you're going to get these elimination problems where we can't really multiply 4 by something to make it look like the 5x here, or a negative 5x, and we can't really multiply 3 by something to make it look like a 5y. So actually, in this case here, we got to multiply both equations. So these are a little bit more tricky here, just because you got a little bit more going on. So I asked myself, what do I want to cancel out? Do I want to cancel out x's or y's? Let's go with y's in this case. It doesn't really matter, but I'm going to go with y. So I need to figure out a number that 3y and 5y can go into. Right? So if you think about like the smallest number, you could go like 30 or 60, but the smallest is 15. So I want something to look like 15y, and then the other one I want to look like negative 15y. So let's say this first equation right here, if I want that to look like positive 15y, I'm going to multiply this entire equation, or both sides technically I'm supposed to say, but I'm going to multiply everything by 5. All right, as long as you do everything to both sides of your equation, you should be good. So I guess I'll go ahead and write it off here to the right. That'll get us 25x plus 15y. And then, oh yeah, check this out here. 0 times anything is 0. So that came out pretty clean. And then let's look at what's going on here with these, the second equation right here. So I want 5y to look like not 15y, but negative 15y. So not only do I need to multiply by 3, I need to multiply by negative 3. I'm going to do that there, distribute to everything. 3 times 4, I think that's negative 12x. Negative 3 times 5y is going to be negative 15y. And then 3 times 13 is 39, but negative 39. And then now we can go and combine your equations. Okay, so if we combine up our equations, of course the y's canceled out. That's how we designed our equations come out. Got 39 on the other side, or negative 39. Then over here on the right-hand side, I guess you have, looks like 13, so 13x right there. Then now, let's go divide by 13 on both sides. That's x is equal to negative 3, and we're good to go. Now, take that x is equal to negative 3. We're not done there. We're about halfway done. We need to go plug that back in to one of your other equations. So I'll plug it in. Oh, I guess we're doing straight line there. We're going to plug it in. That first one looks pretty easy, 5x. Actually, we know what x is, so 5 times negative 3, and 3y, and then equals 0. I think that's negative 15. Add negative 15 to cancel it out. So 3y is equal to 15, and divide by 3, and y is equal to 5 right there. Now, some people might say, I can kind of see someone getting confused, like, oh, does that mean the answers are what you distribute by? Not necessarily. That was just a coincidence there. So that is it. I guess we can write it as an ordered pair, negative 3, 5, and we're good to go. So that's a little bit of elimination. If you need extra practice or need extra help with those, let us know. I'm sure there's plenty of videos YouTube where you can go watch more examples, but we're kind of assuming that you guys are going to catch on to that real quick. Okay, example 3 here, I like this here because you got some weird solutions that are going to happen. So let's take a look at what happens here. So when we combine these equations here, notice here y's happen to cancel out and x's happen to cancel out. So over here on the left-hand side, you have nothing left. Okay, now on the right-hand side, the negative 5 and the positive 5 also cancel out, so you have 0 equals 0. And that actually goes back to that situation here when we're talking about substitution a while back. If you have something equals itself, like the same number, 5 equals 5, 10 equals 10, 0 equals 0, if you ever have that there, we say that is a situation when they're the same exact equation, or you have infinitely many solutions. Watch out, they will throw those at you every now and then. We're going to see something similar here with this one, except the x's and the y's, they all cancel out, so you have 0 over there on that side. But on the right-hand side, you're going to actually have 16. 0 equals 16. And if that happens right there, we say, once again, that was no solution, because that was a contradiction. You can't have 0 equals 16. So, there you go. All right, now I think we've got a couple more here. We're going to set up some word problems. Real big on this test here, the word problems with two equations and then two variables, and then we're going to solve them out. So let's see if we can handle it here. So you ride an express bus from the center of town to your street. You have two payment options. Option A is to buy the monthly pass and pay 75 cents per ride. Option B is to just pay $2 per ride. The monthly pass costs $25. I guess that's implied to be once. After how many rides will the total cost of the two equations be the same? So let's see what's going on. First of all, we want to define our variables. So we're going to say like x is something and then y is something else. So let's say x, or you don't even need to use the x here. Let's get real fancy with our variables here. So we are trying to find how many rides right there. So that's, let's call that R, I guess, the number of rides there. And then I guess the cost is going to be the other variable. Okay. So the cost for the first option, option A, is 75 cents per ride. All right, so the ride was R. But option A is if you buy the monthly pass, which we said was a one-time fee of $25. We're going to do 75 or 0.75 R plus 25. And if you want to use X and Y, once again, you can do that. It does not matter. Okay. So the cost for the second situation here is actually just $2 per ride, no flat fees or anything. So I guess we're going to go and figure out how many times do you need to ride for basically the cost to be the same, or to pay for the cost, that initial $25 that you spent there. Okay. So we need to decide, okay, is it going to be substitution or elimination here? These are both actually solved for the same variable, so let's do substitution here. Let's take that 2R and actually plug it in on this right-hand side. We'll say 2R equals 0.75R plus 25. Elimination is the best method right here. I'm sorry, substitution is the best method here. Okay, and then we're going to subtract off. We've got to get the R's together, so subtract off your 0.75. If you're not comfortable with decimals, I like to think in terms of money, so it's like $2 minus 75 cents. I think it's 125. And then I guess that equals the 25 left over on the right-hand side. And then we just need to see how many times 25 is divided by 1.25. So after you divide, that gets us 20. Rides, the number of rides you need to go on are 20. Now, they didn't ask for this, but if we wanted to go figure out what that cost would be, we could just go plug back into one of our equations. So we could go C equals 2 times the number of rides. Doesn't matter which one, you should get the same cost no matter what. So that'd be at $40. Now, like I was saying, for the select, if you want to get real fancy here, you can say R is how many rides. And then C was the cost. And then our answer, I guess we need to say something like 20 rides on the bus. That's how you tackle a word problem. Now, they're not all going to be set up like that. This is kind of like in that y equals mx plus b form. Sometimes you'll get the ones that are like in standard form where x and y are together. It just kind of depends on the question. So let's see what's going on with this one here. Soccer League offers 2 membership plans. Option A has an initial fee of $40 and it costs $5 per each game played. Option B costs $10 for each game played. So this one's got a lot of similarity here. So I guess we can say G, we'll say it's the number of games. And then I guess C we'll call it cost again. Okay. And then let's see, for option A, the cost was an initial fee of $40 and then $5 per game. So we'll say 5G. I guess the second one here, what do you got? Option B was just 10 per game. This one's almost identical with just different numbers in a different context, but it's got the same idea. We'll use substitution. We'll substitute in for that C right there, the 10G. The 10G equal to 40 plus 5g. Get your g's together. We can subtract 5 from both sides. That's 5g is equal to 40 once you do that. And after you divide, I guess you're going to get 8. So that'd be 8 specifically games. Okay, as far as the cost goes, they didn't ask for it specifically here, but if you wanted to go back and find the cost, to go plug back into one of the two equations. Let me do the other one just for kicks. But that would be 40 plus 40, that should be 80. So that would be a total cost of $80 specifically there. Okay, so that is that. Alright, let's see what's going on here with this last one, actually. Right here. So we got at a pizza restaurant, it costs $4 to make a small pizza that sells for $12, and then it costs $6 to make a large pizza that sells for $15. In 1 week, the restaurant spent a total of $1,100 making pizzas and sold all of them for $2,910. How many of each pizza were sold? So I guess we're going to have two different things here. So the way I see it, you have like a cost, like it costs $4, costs $6, and everything costs together $1,100. And then I guess the other situation here is dealing for what the selling is. So I guess there are two equations that are going to compare your selling price and your cost. So you got sells for $12, the large sells for $15, and then sold all of them for $2,910. So how many of each were sold with those numbers in? So let's do the cost equation first. We need to define our variables too. So I guess we don't know the types of pizzas, so we can call S for small pizzas. I guess we'll say small number of pizzas. And then I guess L we'll use for large number of pieces. Okay. So for the cost equation here, I'll even color code it here. We'll do it in red there. It was 4 per small. And then the larges, okay, yeah, $6, 6 per large. And that came out to a total of $1,100. By the way, if you ever see total, typically that means you're going to add two things. And here's your two things that you're adding. A total is usually something plus something else. Almost always there. Now, as far as your what you're selling your pizza here for, we were selling smalls for 12. So it's 12 times S. The largest we're selling for 15, so 15L. And then we made $2,110 on that. And then after this, we can use substitution or elimination. Now in this case here, I think elimination is going to be better. There's not really a good variable to solve for. You could probably find one of them. But here I'm looking, I could probably manipulate this 4S and make it cancel out with this 12S, which is exactly what I'm going to do here. So if I want to cancel out my S's, I need it to look like, I guess, 12S and negative 12S. So this one right here needs to look like a negative 12S. So I'm going to multiply everything in the equation by negative 12. Cancel it out, or no, not negative 12. Let's try negative 3. I need it to look like 12. My bad there. So that'll get us negative 12s. Negative 3 times 6 right here. That would be negative 18. And then negative 3 times 1,100. I guess is going to be negative 3,030, kind of like that. And then we can combine our equations up and see what we get. The S's should cancel out. Okay, we designed it that way. I think we have 3 L's left. And then as far as the difference here, it looks like 90. It's like 390. that's going to be negative. But some of y'all might be saying, well, okay, it can have negative $300, but this other side's negative as well. So it looks like negative 390, so I guess we can divide by negative 3. And that should cancel out our negatives. That should be 1, 3, I guess 0 right there. So 130 larges. Right there. So that was the number of larges. We still need to go find the number of small pizzas here. So we'll go and do that. And we can do that by plugging back into one of our equations. So I'm going to go 4s plus 6 times L, and then equals 1,100. And just so I don't have to do any thinking here, I'm going to pull up the calculator. 4s, 6 times 130 is 780. And then equals 1,100. I'll subtract that. And that gets us 320. And then we can divide by 4, which should be 80. So then after we do all of that, then we can say we sold 130 larges and 80 small pieces. I believe that is it here for today.